Okay, in this last video for Chapter 5 of Industrial Organization, we're going to talk about comparative statics, basically meaning, well, what happens to the equilibrium in perfect competition when something changes? Demand changes, supply changes, etc. And then we'll look sort of at a little, some more details about perfect competition, why we think it's useful in terms of measuring efficiency, why it might not be useful in terms of measuring efficiency, thinking about sort of the difference between what a static model is telling you and what a more dynamic model would be telling you. So let's get right into it. So comparative statics is basically just saying, okay, well, here's our model that shows an equilibrium. This is how sort of price and quantity are related, both on the consumer side and the firm side. But that just talks about price and quantity, right? We know there's lots of other variables that determine both demand and supply. And so what happens when one of those exogenous variables, exogenous meaning outside the model, right, not price and quantity, changes? And so if we get a change in an exogenous variable that affects either demand or supply, then we would expect those curves to shift, right? Whereas if we get an endogenous change in price and quantity, price or quantity, then we would sort of move along one of those curves. And of course, what we will generally have when we get an exogenous shock, so let's say we have a normal good, income goes up, that means people want to buy more of the good, so that's an increase in demand, right? So our demand shifts, right? That's our exogenous shift, but then because of that increase in demand, we're going to move up the supply curve, and so price and quantity are going to increase. Those are our endogenous changes. And so that's what comparative statics really sort of allows us to do. Should be mostly a review for everybody who's had principles of micro, and definitely if you've had intermediate micro. So just a couple of examples. So on the left here in figure 510, we have an increase in demand. And so our initial equilibrium is here at point A at Q1 star and P1 star, and demand increases. Why does demand increase? Well, could be a number of reasons, right? Could be that income goes up, and so people want to buy more of it. It could be that, it's more popular all of a sudden. Tastes have gone up. It could be that the price of a related good has changed, right? So if the price of gasoline goes down, then the demand for big SUVs goes up, right? And so what happens is people now want to buy more at every price. And so that's what that shift from D1 to D2 is. Now, if we were here and we need to go here, how do we get there? Well, we need to increase supply, right? But it's not a shift in supply. It's just a movement up the supply curve as firms produce more, right? And so now we go from P1 star to P2 star, price increases, and we go from Q1 star to Q2 star, quantity increases. So that's an increase in demand. We could do the opposite where there's a decrease in demand. Let's go over here to figure 511, where we have an increase in supply. So here we are at point A. We get an increase in supply. So what could have happened? Well, more firms could have entered the market. We could have an increase in technology, right? Somebody invents something new, right, which decreases the cost of production. Again, there could be something going on in a related industry, but we're producing more quantity at any given price, right? And so that's our shift in supply. And then what happens? Well, now consumers want to buy more because the price is lower, and so consumers do buy more, and we move from A to B along the original demand curve. And again, we can do the opposite where there's a decrease in supply. That would lead to, higher prices and lower quantity. In this example, with an increase in supply, we get higher quantity and lower prices. All right, so let's talk about efficiency and welfare and what we sort of mean by efficiency, right? So we're going to talk about sort of 4 definitions of efficiency. The first is technical efficiency. And technical efficiency basically means that a firm is using the minimum amount of, inputs in order to produce a given output. There's no waste, right? And we expect, over time, firms to become more efficient if you look at the data, what you find is that there's a pretty broad um, range of efficiency within a given industry, where bigger firms tend to be more efficient and smaller firms tend to be less efficient. When we talk about economic efficiency, right, it means that we're producing it at a minimum cost, right? And so a firm is economically efficient when it produces a given output at a minimum cost. Now, that could change, right, with technology changing. But basically, we're assuming that firms are not wasting any inputs. And I think that's a good way to think about efficiency, really, is that nothing's being wasted. So if we see waste in a firm, in an industry, in an economy, that's how we can tell it's not being efficient. Then we can have productive efficiency, right? So productive efficiency is that the whole industry now is producing a given level of output at a minimum cost. So this basically says not only do firms have to be efficient individually, but the whole industry has to be efficient. That's a big ask, right? Because I just said we tend to see that bigger firms are more efficient than smaller firms, but we also see that these smaller firms often exist. And so most industries, I think we could argue, are not productively efficient, but that's going to vary depending on the industry. And then we have allocative efficiency, right? And this is sort of the one that touches most on welfare, or at least most directly. And so the industry, we can say, is allocatively efficient when it produces the socially desirable quantity of output. What does that mean, socially desirable quantity of output? Well, if there are no externalities, right? So there's nothing outside the market that's a cost or a benefit, then okay, then we can say maybe that long run equilibrium is allocatively efficient. But as soon as we have any type of externality, right? So any kind of pollution, or even a positive externality, like with maybe education, then we're probably not going to be allocatively efficient, right? And so, we'll talk later in the semester about ways we could, put taxes or subsidies in these industries that are not allocatively efficient to try to move them in the right direction. So, as I said right earlier in the last slide, efficient firms, just because every firm is efficient doesn't necessarily mean you have an efficient industry, right? If you have a bunch of small firms that are all sort of being as efficient as they can at that size, that doesn't mean that they couldn't enjoy economies of scale if they all got bigger, right? So if we, grouped a whole bunch of them together, and then they could afford, better technology, etc., then that could reduce the costs. So efficient firms don't always translate into efficient industries, and we do see that, right, where we have, especially, when we think about mergers and acquisitions, right? One of the arguments for mergers and acquisitions, other than increasing the pay of the people involved in the merger and acquisition, is that by, combining and increasing in size, there will be increased efficiencies. Sometimes that's true, sometimes less so. What we would like to see in the long run, right, is having the number of firms, whatever that number is, that minimizes industry production costs. Now, this can be a little tricky, right, if we have a decreasing average cost curve, because that says that the more one firm produces, the lower is the cost, and so that's generally what we call a natural monopoly. Most industries we don't necessarily think of as a natural monopoly, and then if we start thinking more dynamically, we can start thinking of reasons why we wouldn't even want one firm to monopolize, even if it did have a decreasing average cost curve. So how do we sort of measure efficiency? Well, sort of basically we measure it with surplus in a market, right? And so consumer surplus is the difference between what a consumer is willing to pay, right, on the demand curve, and what the consumer actually pays, so the price. And producer surplus, similarly, is the minimum that a firm would accept and the price. And so our maximum total surplus, right? So here, if our price is P star and Q star, then our consumer surplus is the triangle A, P star, C, and our producer surplus would be the triangle B, P star, C. And that would be the maximum surplus that we could have, and so that would be the most efficient outcome in this market. The example here is like, all right, well, what if we're at P star, but because of whatever reason, we're only producing at Q prime? Now our consumer surplus is this, trapezoid or something? A, P star, E, D, and then the producer surplus is B, P star, E, F. And then what happened to our triangle FCD, right? Well, that's just disappeared. And that's why we call it deadweight loss, right? It's trades that never even happened. And so often what we're concerned about in economics is trying to minimize deadweight loss, because deadweight loss represents sales that firms would have made, right? And that consumers would have bought, but because of whatever reason, in this case, it could be like a quota, those sales didn't happen. In the case of like a monopoly, right, the price would be higher. It might be up here somewhere, and the firm is making a profit maximizing decision that the little triangle that they lose is smaller than the big rectangle that they gain. But from a market perspective, we're losers. So we'll talk about that a fair amount when we're sort of comparing the different markets and outcomes to perfect competition. So total surplus, right, which we just said is the sum of consumer surplus and producer surplus, measures sort of total social welfare. Now, some economists will be like, no, that you can't measure social welfare. That's just silly. And okay, that's fine. Think of this as like a measure of like how much people are benefiting, which sounds a lot like welfare, but that's all right. And so total surplus, right, which is just the area under the demand curve and above the price, and the area above the supply curve and under the price, is some measure of social efficiency, right? If we're close to P star, then we're closer to be efficient. If we are far away from P star and Q star, then we're not being efficient, and we have to figure out why that is, and if there's something we want to do to try to get us closer to that sort of perfect competition outcome. Now, I think we have to ask ourselves, is perfect competition really efficient? Because what did we say? We said, well, in perfect competition, total surplus is maximized, but economic profits are zero, right? And because marginal cost is equal to average cost, right? And average cost is equal to P star, right? That means profits are zero. And we can say it's definitely statically efficient, right? So if we were all, if all firms are technically and economically efficient, and then the industry is productively and allocatively efficient, right? At least from a static point of view. But with zero profits, our firm's going to enter the market. With zero profits, our firm's going to innovate, right? And innovation is really the key to technological improvement, right? That sort of rightward shift in the supply curve. And so someone like Joseph Stiglitz would say, no, this is not what we should aim for. We should aim for firms that have an incentive to innovate, whether it's on the product side or the process side, right, the cost side, in order to increase their profits. And we should be willing to accept that in the short run, which is always, right, we're always in the short run, we're not going to be, at that perfect competition equilibrium, and we should be okay with that. What we shouldn't be okay with would be, one firm monopolizing the whole industry, because then that one firm, will do everything it can to keep competition out and will have no incentive to innovate, right? And so we want to sort of try to balance a little bit the statically efficient market with a more dynamically efficient market as well. All right, so then we have to think about market failure, right? And what do we even mean by market failure? So if we have perfect competition, if perfect competition is sort of like our Platonic or Socratic ideal, then anything that moves away from that we could consider to be market failure, right? And so one thing that we'll talk about is market power. And by market power, all we really mean is that firms are able to price above marginal cost for whatever reason, right? So it could be that they're a monopoly, definitely market power. They're the only firm producing, so they're going to choose the point on their demand curve that maximizes profit. It could be because of some level of innovation, right? You make a better product and people want to buy it. The other firms can't make that product, and so you are, in a much better position to price above marginal cost. But as Joseph Stiglitz would say, well, as long as that doesn't last forever, then that's probably a good thing. Otherwise, the firm might not have innovated ever. So we'll talk about market power a lot. The other source of market failure, of course, another source, not the only other source, would be pure public good. So a public good is non-rival, meaning if I use it, you can still use it. And it's non-excludable, meaning I can't prevent you from using it if it exists. So like a public park, an empty movie theater, an empty road, those are all public goods. And free markets generally don't supply enough public goods because there's no way to charge really for it, right? So there are ways, right? So, there's a reason that movies happen inside where you can, take a ticket rather than outside where everybody could watch. But this is an example of a free rider problem where you can consume the good without paying for the good. The other, of course, major source of market failure are externalities, right? So an externality is any cost or benefit to a market transaction that goes to someone who is not the buyer or seller, right? So if all of the costs and benefits go to the buyer and seller, then we don't have to worry too much about this piece. But as soon as there's something like pollution, then there's an external cost going to people that had nothing to do with the transaction. Every time I burn a gallon of gasoline, I'm putting pollution into the air that's affecting everybody, even if just a little bit, right, for that extra gallon. But if lots and lots of people do it because those costs are not being put into the price, then now all of a sudden we have lots of pollution, we have a problem. We can also have positive externalities, right? Positive externalities are a benefit to a market transaction. And for those ones, so, for negative externalities, we probably want to put on some sort of tax or limitation. For positive externalities, we want to put on some sort of subsidy. A network effect, or, I guess we could call it a network externality, comes about and is more and more common, I think, in our digital age when the benefit of using something increases or decreases when somebody else is using it, right? So if we're all using Snapchat, then that makes Snapchat more valuable, right? Even if there's another app that's exactly the same as Snapchat, if there's nobody on it, nobody's going to use it. If we're all using Microsoft Word, or now we're all using Google Docs, then that makes them more valuable. And so this is a big issue, and I think is one of the things we want to talk about this semester because our sort of antitrust laws were built for a world where firms were trying to monopolize commodities, especially, right? Steel, oil, railroads, etc. Whereas now our sort of biggest firms are biggest because of these network externalities, right? These network effects. And it's not clear that our policies that were, aimed at U.S. Steel are going to be the same, or is going to be usable really for, tackling Google and Apple and Meta. So finally, another market failure that we need to talk about is this idea of imperfect information, right? And so with imperfect information, that means that either the supplier or the buyer doesn't know something about the product or the transaction, right? And so the famous example in economics is used cars, where the seller might have, much more detailed information about the quality of the car than the buyer. And if the buyer can't figure out the quality of that car, then the buyer is going to assume that it's lower quality. That pulls all the higher quality used cars out of the market, leaving only lower quality cars. That means that the consumers are going to be even less likely to buy those cars, and the sort of market fails to exist. There are ways around that. You know, if you think about someone like CarMax or Carvana, national chains that offer, you know, some warranty period for used cars, they're definitely trying to solve that problem. And then we can also have sort of behavioral factors, right? And behavioral factors include, you know, overconfidence and overexuberance, but it also includes sort of taking advantage of, you know, consumers' own behavioral factors and marketing to them in such a way that we don't necessarily get the best outcome because consumers are buying things that they maybe aren't good for them or that they didn't really want to buy. All right, so we'll stop there. So that's the end of chapter 5. We're moving on to chapter 6, and we'll take it. We'll see you back there.